Let's get straight to the point. Extinguishing the sun with water is like trying to put out a forest fire by tossing a snowball at it. It's a mismatch of cosmic proportions. But since this is a hypothetical question, let's dive in and figure out just how much water we need. First, the sun isn't a campfire that can be doused with a bucket of water. It's a massive ball of hydrogen undergoing nuclear fusion, a process where hydrogen atoms smash together to form helium, releasing immense amounts of energy in the process. The temperatures at the sun's core reach about 15 million degrees Celsius, and even the surface is a sizzling 5,500 degrees Celsius. So water which boils at 100 degrees Celsius is going to have a rough time here. But let's say we're going to try anyway. To extinguish the sun, we'd need to cool it down enough to stop the fusion reactions in its core. This means reducing its temperature to below 10 million degrees Celsius, where fusion begins to falter. Cooling something that hot with water is a monumental task, so let's crunch some numbers. The sun's total energy output is about 3,860 trillion watts. To counteract this energy with water, we'd need to account for the specific heat capacity of water, the amount of energy it takes to raise the temperature of water by 1 degree. Water's specific heat capacity is about 4.18 joules for every gram of water to raise its temperature by 1 degree Celsius. Additionally, we'd need to consider the energy required to turn water into steam, known as the latent heat of vaporization, which is about 2,260 joules per gram. For simplicity, let's assume we're starting with water at room temperature, 25 degrees Celsius. To cool the sun, every gram of water would first need to absorb enough energy to heat up to 100 degrees Celsius, then absorb even more energy to turn into steam, and finally absorb even more energy as steam continues to heat up to match the sun's temperature. The numbers here get ridiculous quickly. Even if we ignore the practical challenges of transporting water to the sun, and by practical challenges, I mean impossible tasks, we'd need a truly astronomical amount of water. How astronomical? To cool the sun just 1 degree, we'd need more water than exists on Earth, by a lot. In fact, you'd need so much water that the combined mass of it would outweigh the sun itself. And when you add that much mass to the sun, gravity takes over, and instead of cooling it down, you'd create a bigger, hotter star, or potentially trigger a catastrophic event like a supernova. Oops. But let's go further. What if somehow we had an infinite supply of water and managed to dump it all onto the sun? The water would vaporize instantly, creating a massive cloud of superheated steam. Instead of extinguishing the sun, you'd end up surrounding it with a dense, scalding steam blanket, making things even hotter and more chaotic. In short, adding water to the sun is like trying to put out a grease fire with water. Doesn't end well. So how much water would you need to extinguish the sun? The answer is simple. An amount so vast it's meaningless, and even if you had it, you'd probably destroy the sun and everything around it in the process. The sun's fusion reactions aren't something you can put out with water. They're driven by the fundamental forces of physics, forces that laugh in the face of our puny water buckets. In conclusion, the sun is going to keep shining, no matter how much water you throw at it. And that's probably for the best, since we kind of need it to survive. Hypotheticals like this might be fun to think about, but when it comes to extinguishing stars, it's best to leave them alone and just enjoy the sunlight.